Hey everyone, so this lesson I'm going to go over multiplying radicals. The do now talks about a polynomial that was factored as this and what are the values of a and d and explain how you arrived at your answer. So first off, you could go for it and multiply at the whole thing with box method. Like, I think it would take you 2 steps, but there's a shortcut with this to get a and d. A, if you notice, is the first letter here. So to get your a value, just multiply all the first numbers here. So this would be 1, 1, and 1. So 3 times 1 times 1 times 1. So a would be 3. And then to get your d value, you'd multiply all the last numbers. So -2, 3, and -4. So -2 times 3 is -6. And -6 times 4 would be 24. But you still need to include the 3. So if you multiply that by 3, you end up getting 72. So you would just explain that you multiplied all the first terms and all the last terms of the binomials inside of the parentheses, and then you multiplied those by 3, because that's the outer coefficient that's like going to be distributed. Okay, so to multiply radicals, what you want to do is first, first check that the radicals are the same type. So check the radicals are the same index. So what I mean by like index is cube root, square root, etc. And then you're going to multiply the radicands, which is the inside of the radicals, and then you're going to simplify. So for example, for a here, I would check that they're both square roots, and they are. Then you're going to multiply the insides, which gets you 18. Then you're going to simplify. Factors of 18, where 1 is perfect, is 9 and 2. This will reduce to 3, and this will reduce to 2. And that's your answer. Same here, square root of 14. The thing about 14, though, there's no factors inside of it. That's a perfect square, so that's simplified. Okay. There's numbers in front of this, so all you're going to do is multiply 6 times 3 over 2 first, and then you'll do 5 times 10, which is 50. So that's the inside of your radical here. 6 times 3 is 18. Divide that by 2 is 9. Break up 50. The factors of 50 where one number is perfect is 25 and 2. Again, you can go to your calculator, look at y equals, and look for your factors where one of them is perfect. And then 9 times 5 would be 45, and then rad 2. Okay. Same deal here. I would multiply 5, 6 times 3/5 first, because there's the numbers. And then 6 times 15 would get me 90. So when you multiply these fractions, they actually, when you have multiplication of fractions and they're set up like this, you can reduce diagonally, and that would just cancel out the 5s, and then you'd be left with 3 over 6, because with fractions you multiply across, if you guys remember, and then it's reduced to 1/2. 90 breaks up into 9 and 10, and then this will become square root of 9 is 3, and then 10. This is over 1, so this is going to reduce to 3 over 2, because 3 times 1 is 3, and 2 times 1 is 2, rad 10. Okay, next one. You're going to distribute this in. You're only going to multiply the radicands, though, because there's no number in front. The only number in front is 1, so this will be 2 rad 4 plus 3 rad 12. Then you're going to simplify the radicals. So square root of 4 is already perfect, so that becomes 2. But then 12 you got to break up. This breaks up into 4 and 3. That 4 will become a 2, which becomes 6 rad 3, and then 2 times 2 is 4, so this is your final answer. We cannot combine these because this does not have a radical, so remember that from your adding and subtracting radicals lesson. Oh boy, what happened there? Okay. This one, though, has a number in front, so you have to be careful of that. There's a 1 here, just so you guys know. You're going to distribute the whole thing in to the 2 radicals inside. 3 times 1 is 3, 2 times 6 is 12, minus 3 times 4 is 12, and 2 times 18, double that, you'll get 36. Square root of 36 is already perfect, so we're going to make that a 6, and then 12 times 6 is 72. Then you're going to break up 12. This is 4 and 3. Again, we're picking 4 and 3 because 4 is a perfect square. Let's look at me 3 times 2, rad 3. Let's look at me 6 rad 3 minus 72. I cannot combine them because the other one doesn't have a radical 3. Okay, moving on. With this, you're going to see that there's a squared here. Do not do this. Do not distribute that in. No. You need to write this out twice because there is a plus sign in between. So it'll become 1 plus rad 3 and then 1 plus rad 3. And then you're going to do the box method or FOIL, whatever you prefer. 1 times 1 is 1. 1 times rad 3 is 1 rad 3, which is just itself. Same thing here. And rad 3 times rad 3 is rad 9, which is just 3. This is a fun fact here. When you multiply a radical by itself, it gets you the inside always. So like if you had rad 4 times rad 4, that's rad 16, but that reduces to 4. So whenever you multiply the same radical inside, the radical. So rad 3 times rad 3 is rad 9, which is just 3, which is the inside. So this actually simplifies very nicely because 1 plus 3, because these guys are both outside the square roots, is 4. And then these combine because they're like radicals, and that gets you 2 rad 3. So I would, of course, suggest at this point that you pause the video and try this one on your own. 25, 5 rad 2, negative 5 rad 2, because you're doing a negative 1 times a 5. That's what's happening there. And negative 1 times 5 is negative 5, which always goes in front of the square root. And then negative 2, because square root of 2 times the square root of 2 is square root of 4, but that just becomes 2. All right, 25 minus 2 is 23, and then these guys cancel out because they're opposite signs. Whenever you have a radical, like a binomial with a number and a radical, and you're multiplying them and they're opposite signs, the insides always cancel out. It's kind of very similar to dots, whereas when you would multiply the factors of a dots problem out, the middle terms cancel. These are called conjugate pairs. They're called conjugates when they have the opposite sign but the same two terms, just the middle sign is different. When you have a conjugate, the middle term cancels out when you box method them. So the same thing should happen here because of the same terms but separated by different signs. And you'll see here, look. So 49, because 7 times 7 is 49. Then you get 14 rad 5, because 7 times 2. And then negative 2 times 7 is negative 14 rad 5. Look, they cancel out because they're same thing, opposite signs. Then you get negative 4. Rad 5 times rad 5 is just 5. Or you can think square root of 25, but the square root of 25 is 5. And then I'm getting 49 minus 20, because 4 times 5 is 20. And then 49 minus 20 is 29. You could actually plug this whole thing into your calculator and get the answer. It'll pop out like that with the correct parentheses and the correct radical, of course. Okay, same thing here. Again, I would suggest that you pause the video at this point and you try it on your own. These are not conjugates. They're not going to cancel out, so don't look for that to happen here. These are different numbers and different numbers in front of the radical. Okay, so this is negative 1, so negative 1 times 4 is negative 4 rad 3. 3 times 2 is 6 rad 3, and then 3 times negative 1 is negative 3. Rad 3 times rad 3 is just 3, because remember, rad 3 times rad 3 is square root of 9, and square root of 9 is just 3. These guys are like radicals, so they'll combine to 2 square root of 3. Plus 8, and this is negative 3 times 3, so that's negative 9. These guys are alike, so they'll get you 2 rad 3 minus 1, because 8 minus 9 is negative 1. Okay, and then the last question says, the length of a rectangle is represented by this expression and the width is represented by the other. What's the area? So you guys should know that area of a rectangle is length times width. So all they're really doing is asking you to multiply these two things. And you can just go ahead and box method this. So again, I would suggest pausing the video and trying this on your own. 6 times 3 is 18. 3 times 2 is 6, rad 12. 4 times 6 is 24, rad 3. And then 4 times 2 is 8. 12 times 3 is 36. I'm going to write this out in a line. Oops. And then I'll simplify. Well, 36 is already perfect, so that becomes 6, and then that becomes 48. And 18 is already done, so I will just write that down. Okay, and 24 is also already simplified because square root of 3 cannot be broken down any further, so the only thing I have to simplify right here is 12. And we know that 12 breaks up into the square root of 4 and the square root of 3. And square root of 4 is 2. So 6 times 2 is 12, rad 3. And then you're just going to combine. Well, let's see. 18 plus 48, that is 66. These are like terms here. And then these guys combine to 36, rad 3. And looking at your choices, that would just be choice 1. So remember when you're multiplying radicals, to multiply the coefficients and then multiply the insides and then simplify. And if you multiply the same square root by its partner, the inside just comes out.